Okay, so I'm going to be doing my peer teaching video on mitosis and cell division. I don't know how many of you have actually seen the clear cell models that they sell online and in teacher resource magazines and catalogs. They're pretty cool. They're made of clear polyester resin, so you can see through the membrane, see the organelles and whatnot floating around inside. You can actually open them up, take the parts out, and manipulate them, put them back together. They're really nice. Unfortunately, they're also really expensive. I haven't gotten my school to spring for them yet. I don't know about how funding is at your schools, but for me at least, getting enough for even a class of 10 to 12 students, small group students, has been problematic. For a full class of 20, 30, 40 kids, it's going to add up to a lot of money. Schools usually, that's not going to happen. So what I've done instead is I've had my students make their own cell models. Okay. It's a very easy activity. It's hands-on. It's actually pretty fun, and it has a lot of longevity. You actually get to use it several times over the course of a semester. So what I start with is a simple paper plate. This is actually a foam plate. I like the foam ones because they're pretty sturdy. It's harder for the students to break them, and when they inevitably spill something on it, the plate doesn't care. All right? It's going to last you a long time. I then give them scratch paper, usually just blank printer paper, and I have them draw out and color their own organelles, chromosomes, and other key cell structures. And so I've got some samples here. And so we've got a poorly drawn chromosome. I'm famous for my bad drawings. Some poorly drawn ribosomes. Sorry about the lighting. There we go. Got a poorly drawn mitochondria. Where'd you go? There we go. Poorly drawn mitochondria. And my less than poorly drawn rough endoplasmic reticulum. Pretty proud of that one. It's a shame I didn't draw myself drawing that one because my students are never going to believe that I actually drew that. Of course, I had no witnesses. All right, so you put all your parts onto your base. You try to have your students draw them somewhat to scale, and they can actually see how it's all laid out in the cell body itself. So the outer boundary would be your membrane, and when you're doing mitosis, obviously you'd have a lot more parts, but for your chromosomes, you'd have your students draw them out several times. Where'd you go? You were just there. Of course, now the computer doesn't want to see it. Okay, so you're going to have it drawn several times, some together, some apart. Generally, I have students color code them, so one will be red and the other would be blue. Yeah, there they are. Okay. That way, when they split later, they can actually see that half went one way, half went the other way, and that each daughter cell ends up with a piece. Okay. Now, you can do this activity several times, like I said. First one would be when you're talking about first getting into animal cells. All right, so you can have them do this right at the very beginning so they can learn about the key organelles, they can learn about mitochondria, ribosomes, Golgi complexes, whatnot. Okay. And this would be a hands-on activity right at the beginning of the unit. And then a couple weeks later, when you get to mitosis, you can have them pull them back out, or if you have room, you can stash them yourself and give it to them again. Have them make the extra pieces that they're going to need for the different phases of mitosis. And then they can manipulate it themselves, pull it apart, and actually see mitosis in their own hands on their own desks or in groups. Okay, and it works out pretty well. I've used it several times. The students seem to enjoy it. It's a nice break from boring bookwork. The mitosis section of pretty much every biology book ever written is extremely boring. I don't know why. And this turns something that would ordinarily be dry academic text into a fun, hands-on arts and crafts project that's pretty simple for them and cheap for you. Another nice thing about this is for your EL students, the academic language for mitosis is brutal. I mean, you've got anaphase and telophase and a bunch of obviously Greek words. They are literally Greek to them, and it's going to be hard for them to pick them up. It's just going to be hard for them to internalize their meaning and put them into context when they're so hard to pronounce and hard to remember. But when you're doing things like this, it's pretty easy to give them an extra plate. Right? And you can write the phase on the back so that when they're doing their manipulation, they can actually see which phase they're doing. Have them take out their phones and take a picture of it. Now they've got notes. Okay? You write the names of the structure, have them write the names of the structures on the back. Now they've got hand-on notes they've drawn for themselves. Okay, they can refer back to it later. They know what they did. For your advanced students, this is something they can easily do at home if you're using the flipped classroom model, which is really nice. It frees up a lot of class time for them to do applications, explorations, microscope work, research, and what have you. So for all around, for most kinds of students, this is really handy. It works nicely into a UDL model, and most importantly, for our standpoint, it's extremely cheap. Right? So give it a shot sometime if you ever find yourself trying to teach mitosis. And that's it.